Okay, today we're going to continue talking about radicals and simplifying them. We worked on multiplying and dividing radicals previously, as well as simplifying the radical. And today we're going to take a look at adding and subtracting radicals. So just as with regular numbers, square roots can be added together, but you may not be able to simplify the addition all the way down to one number. Just as you can't add apples and oranges, you also cannot combine unlike radical terms. In order to be able to combine radical terms, those terms have to be the same radical. For example, it says since the radical is the same in each term, then these are like terms, which means we can combine them. So if we take a look at our first example, we have 2 radical 3 plus 3 radical 3. Notice the number under the radical is the same. If it's the same, then what we're doing is adding outside number with outside number, and we're keeping the radical the same. So we're going to go ahead and add 2 plus 3. Those are the numbers outside the radical. 2 plus 3 is 5. And we keep the number under the radical as is. We don't change that to make it radical 6 or anything. You're combining how many radical 3's that you have. So in the first part of our problem, we have 2 radical 3's. And I add it with 3 radical 3's. When I combine 2 plus 3, I get 5 radical 3's. Our final answer here is 5 radical 3. It works with subtraction as well. If you're subtracting and you have the same number under the radical, you're just subtracting those coefficients, the numbers outside of the radical, and leaving the radical the same. Example 2 says, don't assume that expressions with unlike radicals can't be simplified. It is possible. We might need to simplify each radical individually first and then put it back into our addition problem. So here we have a pretty easy example. I've got radical 9 plus radical 25. Right away, I see that these numbers in the radical sign, the radicand, are not the same. So maybe I'm thinking I can't add them. But you should recognize in this example, they're perfect squares. So the square root of 9 is 3. The square root of 25 is 5. And then they're just plain old regular numbers. And you can add those up to get 8. So you always want to look at your radical to see if it can be simplified before adding or subtracting. Example 3 says you can only combine again like radicals. The first and the last terms contain the square root of 3. So this one plus this one contain the square root of 3. So those can get combined. If I have 3 radical 3's and then I take away 1 radical 3, I'm left with 2 radical 3's. My 2 radical 5 has a different number under the radical sign, so I'm just going to write that next to it, and that's as far as we can take it. We can't combine it further because the number under the radical sign is not the same. We have a few different examples to try, so let's take a look at the first one. It says 2 radical 6 plus 3 radical 6. These are like terms because the number under the radical sign is the same. So if I have 2 radical 6's plus 3 radical 6's, I'm just adding the coefficients. 2 plus 3 is 5 radical 6. And that's my simplified answer. Take a look at the next one. It looks a little more complicated. The first thing I'm going to do is pop a little 1 in here. So I know it's negative 1 radical 80. I'm going to pull my radical 80 off to the side and simplify it. And we've been working with prime factorization. So I'm going to show that. I'm going to rewrite my big old radical as 2 times 2 times 2 times 2 times 5. That's a perfect square. This is a perfect square. That's a single. The square root of 4 is 2 times the square root of 4 is 2 times the radical 5. So this becomes 4 radical 5. But wait, there is that negative sign out in front. So we're also going to bring that up and multiply it by negative 1. So this becomes negative 4 radical 5. We're going to go ahead and pull out radical 125 and see what we can do with that. Where should I put that? I'll put that over here. Radical 125. So right away I know that 25 goes into this. and I know that it's 5 times 25. And 25 could be simplified as 5 times 5. So we write all those single numbers down. We have a double. That becomes a perfect square. So I can take its square root, and that other one stays in. But remember, it was 3 times the square root of 25. So I need to pull that 3 out over here. 3 times 5 becomes 15 radical 5. So I'm going to put that in here, plus 15 radical 5. So we took each of our radicals out separate, simplified them. Whatever we pulled out of the radical, we put out in front. And then we remembered that we had a coefficient already, so we popped that back in with multiplication to get our -4 radical 5 and our 15 radical 5. Now here we can go ahead and combine because we do have the same number under the radical sign. We have radical 5. So now all I'm doing is putting together my coefficients. I have -4 plus 15. That's going to give me a positive 11 radical 5. So they can get pretty complicated. We always want to look for the numbers that we can simplify. Let's take a look at example 3. Example 3, I want to look under the radical and see what I have that's the same. Oh, I have these two terms that are the same. I have 3 radical 5 take away 3 radical 5. Well, they, in essence, cancel each other out, and we're just left with 3 radical 3. So these adding and subtracting problems can be just as simple as this example number 3, or they can get as complicated as number 2. All right, let's take a look at example number 4. Again, I see just a plain old negative sign hanging out in front, so I'm going to add a 1 in front of there. So I have -1 radical 2. My 2 radical 8 is different. My -3 radical 6 is different. So I'm going to see if I can simplify any of these. I'm going to go ahead and pull this guy out. I'm going to put that radical 8 over here. Remember, I had a 2 out in front, so I don't want to forget about that. So my 8 is 2 times 4, which is 2 times 2. This becomes 2 times 2 times 2. I have a set of double. That's square root of 4 times square root of 2. The square root of 4 is 2 radical 2. This is a radical that you're going to see quite often, and if you can memorize what the square root of 8 is, simplified, it's 2 radical 2, then you can cut out some of this middle stuff. But just because we got 2 radical 2, don't forget you had that 2 hanging out in front to begin with, so we're going to pull that in. So it's really 4 radical 2. So far, I have a -1 radical 2 from here. Then we simplified this one, and it became +4 radical 2. And lastly, we have a -3. And hey, I better check. Can we simplify radical 6? Let's see, 2 times 3. Do I have any doubles here? Nope. It's already simplified. So now I'm going to take a look and see what can I put together. I have the same radical 2's, so those are like terms. I have -1 radical 2 plus 4 radical 2. When I put together that -1 and 4, I get 3 radical 2. And then it also says -3 radical 6. That's as simplified as we can go for this one. We started with 3 separate radical terms, and now we're down to 2 separate radical terms. And again, that's as far as we can go because the number under the radical is not the same. They are 2 separate values. So I've got 3 radical 2 minus 3 radical 2. You also can't cancel out those 3's from in front. And that's your lesson on simplifying radicals with addition and subtraction. Remember, this is just like combining like terms. You're looking for the you're looking for the number under the radical sign, which is the radicand. You're looking for that number to be the same. If it's not, you want to pull your radicals out and see if you can simplify them and then pop them back in to add or subtract.